So hi everyone, my name is Ash Davis. I'm a GDE for Android and Kotlin in Berlin, and this talk is on navigation with multi-platform, covering a lot of stuff on Compose and using navigation with Compose and multi-platform, but also be going over a lot of stuff with Jetpack and how we sort of found ourselves here in this journey. So let's talk about navigation in general. So we use navigation like every day in a lot of different form factors and a lot of different ways for a lot of different purposes. You might consider this on how you might have navigation on your Chrome browser, how many tabs you might have if you're a monster. Um, but in simple terms, navigation is simply the process of going from one screen to the next in the scope of your application. So if it was so simple, then perhaps it would be simple enough just to use something like an array deck, where you just have a list of destinations where you can then go back and forward. Well, in theory, we could, but as things go, it's never actually quite as simple as that, because there are many number of complications, and many number of complications in different forms, mostly human. Because there's more than just horizontal navigation, going backwards or forwards. You might compare this to going forwards or backwards in your browser, or going from one screen to the next and navigating back. We've got lots of different types of user experiences and user interfaces that have introduced themselves into Android in the last few years. Things like the navigation rail on the bottom bar navigation, and they're having parallel navigation. So this introduces the concept of not only horizontal navigation going backwards and forwards, but then having vertical navigation where you have a route hierarchy and then you're going through this sort of inverse tree. And that's the thing about navigation. It should be obvious. It should be inherently clear how to operate it. And this is a concept called affordance. Users should be able to interact with something in a way that they expect to. The things like push-pull doors, you shouldn't need an explanation for this. Here is an example of bad affordance. You might be able to guess that it is indeed a tap, but there's no way that you can actually understand by looking at it how to actually use it. So that necessitated the introduction of a sign here. So if you have to explain how to use your product, you're probably designing it wrong, or at least you could be improved. In addition to this, behavior should be consistent with the expectations of the platform. So we've got expectations as Android developers, expectations as iOS developers, as Windows users, and other devices as well. So each one of these own platforms comes with their own interaction and expectation. So this should be consistent. If you start introducing iOS paradigms onto Android, you're going to get a lot of confused people, and maybe even some angry ones. And it's not just the platform as well. We've got different form factors introduced now. We've got things like Wear for Android, and we've got different tablets, different screen sizes. We saw the introduction of adaptive screen sizes with foldables and various other different devices. So, with this added complexity of different UI patterns, we have to make sure we're consistent with the expectation of the user. So even something as simple as navigating back is really actually more complicated than you might think. For example, on a desktop app, where would you think to put the back button? Maybe it's clear to do on a browser, for example, but it's not actually going to be consistent. Think about different apps that you use on a daily basis. Slack, for example, where would you put the back button? It has the little back forward navigation on the top, but every app is unique and inconsistent. So you sort of have to then train your user into using it. So what would be the expected behavior? What would the user expect to have to do? So out of this complexity, Android has not just the up and back, Android also has this up and back navigation, which are not the same things. The screenshot is quite old because it was the introduction of the navigation Jetpack library, but it does demonstrate how the up and back navigation items differ ever so slightly, in that up should never actually exit your application, but back would. Adding to this, our favorite concept of configuration change on Android, where any change to the screen size and your whole world is destroyed, and you have to recreate everything. So how do you recreate that state? Now, this is introducing the concept of complex architecture into something that would just be simple as navigation. But these things are so closely intertwined that we have to make this consideration. Add to this deep links, for example, as well. So if you're linking from a website to a part in your application, you have to then simulate how the user would have navigated to that point if they were to have navigated to it organically. So with all these things considered, we can say navigation is hard, like many other things. It's often a topic of confusion. It's difficult for new developers. It's difficult for seasoned developers. And how do we solve this problem when navigation from screen to screen is such a fundamental part of your application? Well, it turns out we've actually been here before. This was a talk I gave in 2019 in Berlin about navigation during the introduction of the Jetpack navigation library. And it's interesting to consider how we sort of ended up in this situation. Since historically, back in 2016, Dan Hackborn had said this controversial quote that we don't really care about how you build your navigation structure. Once your activity is launched, then you're on your own. But that was not enough for a lot of people, and we sort of needed a bit of guidance, a bit of suggestion about how we should architect our applications, how we should handle navigation. So the Android team introduced Jetpack navigation as part of Jetpack libraries. This was only a suggestion, of course, but it was a very clear guideline about how to build your applications and how to navigate in your apps. So this was Android only and XML based on a navigation graph with some tools to help with integration and implementation and type-safe navigation. And before this, the fragment had been considered the worst thing ever, plagued with lifecycle issues and all these weird backstack management. But despite alternative usage, activities remained the most popular choice. But that was 2019, 5 years ago. Almost a whole Billy Joel song worth of things have happened since then. But this idea of an alternative style of navigation has been floated around before. It's not the only option we have. Back in 2014, the Square folks came up with Mortar and Flow, which was kind of like a molecular UI-based navigation structure. It was using individual kind of view components, view groups, instead of actually fragments or activities, and had this flow sort of handling of navigation with a backstack model. Then continued this idea into the idea of reactive workflows. This is sort of entertaining the reactive ideas like immutability, separation of UI and state, these various things. And they went on to continue development for this with Workflow, which is now in current developments. It's quite comprehensive, very opinionated and open source, which is awesome. It's in production and they use it extensively. It's using unidirectional data flow and encouraging declarative syntax, but it is a little bit overwhelming if you're not used to this kind of ideas. So the team there actually said in public, why should you use it? Well, maybe it's because you work at Square. It's a nice thing to look at and maybe even try it out, but be aware you're going to have to buy into the whole kind of ecosystem there. And it's not just Square that worked on this as well. You might be familiar with the Ribs library from Uber that came out a few years ago, many years ago, employing Viper, which is probably more familiar to iOS folks. It's still in active development, mostly Kotlin, but there are some Java tests and tutorials with shared code between Android and iOS. So not fully multi-platform, but available for both platforms. But besides a few outliers, Jetpack navigation remained the most popular option. It was nice that Google gave a recommendation and people actually had this as a nice thing to use. So fast forward, and we have Compose UI. This was introduced in 2019 at Google I/O, but it didn't reach stable until 2021. So Compose UI was introducing these nice ideas of having a declarative UI framework, making it open source, built primarily on Kotlin, and made it very easy to build UI components. It's actually quite enjoyable to use it. And quite importantly, it introduces this idiomatic Kotlin API to use. So it helps building modern applications. But it's really important to note that Compose is not the same as Compose UI. This is a very important fundamental fact because Compose as itself is just the runtime on which Compose UI is built. Compose is a really nice technology, but it's not tied to this concept of UI. It's just poorly named. So if we consider this Compose as a technology, as a runtime framework that we can actually then employ for different functionalities and different tasks, it gives us a whole new world of options. There's a great talk from Mahit at New York, deep dive into the Compose compiler. Recommend checking it out if you have time. So then back to Jetpack navigation, they continue developments introducing the compose factor to this as well, adding preliminary compose support. You could then introduce composable for navigation, building a navigation graph. You could use the view model so it was scoped to the actual component, the composable composition that you're actually in, and introduces this support for remember savable, so you could remember your destination level scope, and backhandling support. So the NavHost composable DSL looked a little bit like this. This was from a previous version, and I'll explain the differences as we go along. But there was like a simple hierarchy. There was no separation between how you're building your architecture, how you're building your state, how you're building your navigation graph. There's no separation there. You simply got, here's my graph, and then call directly the functions. So it's fine for simple apps, maybe even for beginner apps as well, but it doesn't scale very well. Because you'd have to introduce things like arguments, and then this would be serialized in an ineffective fashion. Of course, this is not currently up to date, but this talk was from a few months ago. But parameters would need to be encoded as strings because they were actually inherently representative of deep links. So you'd retrieve the nav controller from the backstack or the save state handle and use it there to get your objects from the saved instance state. So a bit kind of obtuse and difficult to work with. That was until earlier this year, or a month or two ago, when type safety was added using Kotlin X serialization. This was in September, and is the current state of things for navigation in Jetpack, with Jetpack, sorry. There's more information about the type safety in the development at the Android developers blog. Don't worry about sharing the links to this slides later. Actually, they're already shared on my socials, so you can check them out already. But you know, this talk isn't a talk about navigation on Android. That wasn't accepted. So this is a talk on navigation on multi-platform. So surely you came here to hear about multi-platform, I hope. So multi-platform is kind of the relatively new kid on the block. It's been stable since 1.9.2, released in 1st of November last year. But multi-platform isn't exactly a new concept. It's been tried a few times before. There's many attempts at different multi-platform frameworks, each demonstrating some advantages and disadvantages, some with limited success and some with even less, and some integrating with the underlying OS and some not. I'm not going to name any names here, but yeah. Each framework would specify its own ecosystem to work with, its own development, its own IDE, its own language. And with each one of these languages would have their own ecosystem with libraries, with third-party developers who are building their own applications and libraries. But these things are often built with languages not typically familiar to mobile or Android developers, unless life has been particularly cruel to you. So the nice thing about KMP is that it kind of starts small. It doesn't require you to kind of fully adopt everything to start using it. We're already using Kotlin as Android developers, so we can just start using modular components and kind of get our feet a little bit wet without fully committing. And that's really nice that we can sort of decide how much of our architecture we want to devote to this. We can build components and build systems that make sense for us, make sense for your team, and make sense for your company or your project. The language is widely spread, backed by Android and JetBrains, so with a strong community support, as we all know and love that this is taking off. We had this information from Kotlin Conf 2023 that multi-platform libraries available for Kotlin is increasing drastically year on year. In 2023, it was roughly 1,200. There's no good scales on this graph, so it's hard to say for certain. But then, yeah, Google I/O earlier this year, Google announced Kotlin multi-platform as a primary citizen, which is awesome. And we saw at the Android show yesterday as well that we've got some support in various libraries in Jetpack for Kotlin multi-platform. So things like annotation, collections, data store lifecycle paging, and Room and SQLite. They elaborated as well that the difference between these is some are supported for multi-platform and some are just compatible for multi-platform. The difference being that they're actively engaged or they're just compatible that you can use them in a multi-platform project, but you might need to work a bit on the implementation to get them working as you would expect them to do. So you might notice that navigation is noticeably absent from this list, but for better or worse, view model is now multi-platform. Why? It might become obvious later in this talk that I'm not a big fan of view models. So, adopting multi-platform architecture, whilst there are some Android X components becoming available, we may or may not want to use them, or we may be not already entrenched in using them because maybe we want something a bit more fully fledged, something that takes Compose multi-platform as a first-class citizen, that it's designed for Compose rather than designed for Compose and multi-platform rather than just being an afterthought or kind of adaptive thing. So there are a lot of different libraries that we can use for this that have been around for a little while and have been actively maintained for a little while as well. So I'd like to introduce Decompose and Ascenti from our friend over here. Decompose focuses on the lifecycle awareness aspect of this whole thing, and it's not just navigation, it's just architecture as well. So it provides an abstraction over each one of these layers for different platforms. And in the absence of ViewModel for multi-platform, it does a really good job of abstracting these, so you can use familiar patterns that you have from Android on other platforms as well. I hope this sample is up to date, but maybe you can correct me. But the core principle of Decompose is to provide multi-platform functionality through this component context. So many of these things might look familiar to you if you've used these in Android before. It provides observability and value storage with lifecycle persistence with implementations for those respective platforms. For navigation, it employs the concept of child stacks. Screens are created and provided from the config. It's not inherently Compose, but Compose is provided through extensions. So we've got the extensions for Compose, extensions for Android, and the State Keeper for Darwin platform. So enter Compose multi-platform. We've covered a library that does multi-platform, but maybe want to think about Compose multi-platform. Compose multi-platform builds upon Kotlin multi-platform and became production ready in version 1 at the end of 2021 in December. This is actually provided because it's native to Android, so it's actually just a pass-through for Android. So it's actually using Jetpack and Compose UI for this, and then for other platforms there's the implementation provided. So they changed their sort of stability declarations, so rather than versions themselves being stable, they've gone for platforms being stable. So Android is stable by default because it follows Jetpack. iOS is now considered stable as well, along with desktop and server-side and Kotlin.js. Whether you believe Kotlin.js is stable or not is another question, but Kotlin WASM is also in alpha. Most platforms stable is my point there. But the downside to this is that the development is a little bit staggered. So as Jetpack Compose UI is being actively developed with new features, the Compose multi-platform implementation is usually a little bit slower behind because they have to add the implementations for other platforms, go through a bit more rigorous testing for other platforms as well. So it can take a little bit of time for these new fancy features to appear in Compose UI, in Compose multi-platform. So they often track out-of-date versions, which can be a little bit tricky to find the documentation, for example. So if you're using 1.6.11, that correlates to 1.6.7, and they've already updated the documentation from 1.6.7, so you might not be able to find that unless you're looking on Wayback Machine or something. So I actually thought this was like a really kind of clever witchcraft, what they were doing, shipping these artifacts or something, so for other platforms they were still working. But it's actually just a forked repository where they're putting in a lot of legwork into getting the implementations for other platforms. Now, it's helpful now that Google are making multi-platform a priority, so a lot of things are there for multi-platform as well, so there's less work. But there's a heck of a lot of work going into maintaining this and keeping it up to date. So mad props to the JetBrains dogs. And at the time of speaking, I think navigation is currently available as an alpha artifact. So you can actually now already use the same navigation from Jetpack Compose in your multi-platform projects. So if you want to migrate your existing platforms to multi-platform, then you have this option now. There's more details on the JetBrains Compose site about this. Again, links at the end. So if you're migrating from an Android X navigation project where you're using this already, and you waited long enough, and you can actually have Android X available. So congrats. You just have to change the artifact coordinates, do nothing, and profit. It reminds me actually of an analogy that I often quite like to use. The early bird gets the worm, but the second mouse got the cheese. it's best not to think too much about it. So, considering our architecture goals and how we can use tooling to achieve them, we have this kind of reactive architecture that we want to employ. We have this concept of push, not pull, having this unidirectional data flow, very important for modern application development, having the declarative syntax for your Kotlin applications, and making sure that it's idempotent. This means that you have pure functions that are always going to react the same way every time you operate them. It's also very difficult to say, idempotent. So back in the day, we had callbacks to execute code after something had been executed. We still have this in a lot of places, but it's a very familiar paradigm that we'd use. And you might be familiar with this concept of callback hell, at least from JS, where you have this infinitely nested operations of callbacks. It is not very scalable, and it's not very maintainable, and it's difficult to manage. Before we had coroutines, we then fully jumped into the world of RxJava, where we had everything was a stream, everything was observable, and this became quickly unmanageable, even though it was a nice idea, because it resulted in all these different kind of weird Rx operators. And basically the signal to noise ratio there was just not very good. There's all these different operators about how to convert your stream into something that you actually want. And there's not enough information about what you're actually doing with the application to actually give you enough information. This is a contrived example just to keep it simple. But you can imagine how these things kind of get out of hand. And you might have had first-hand experience with this. I know I have, and I've seen some things. I've wrote some things too. Then we had the coroutines, and this promised to simplify this kind of reactive idea by making this imperative style syntax. So you get to enjoy Kotlin and structured concurrency with coroutine scope and being able to kind of cancel jobs effectively, and have your execution in lines in quite simple way. So you have like very clear declaration syntax here of what's going on and how it's used. So it's very clear and understandable what's going on. But then we wanted to model our state into an observable stream because we have different types of state. You might want to show a loading state. You might want to show something in progress, or you might want to show different types of state, or maybe the users interact with something. So you want to have different types of the same state and have all these sealed interfaces and different types of state classes that we want to do different operations on. So we took coroutines and we made it into RxJava. Go us. But if we're remembering that compose is a tree of nodes, then we can think about this in our architecture as well. So we take the previous example and think about how we can kind of operate this, and how coroutines changed the style of observable syntax into something that was imperative. Well, we can then apply compose on top of this as the runtime to give us something a little bit nicer. For example, like this. So we have this collector's state concept where we're taking a flow of states, for example, and then putting it into an individual parameter. So you have these individual declarations which are line by line separated, and they will be recomposed if something's changed. And you don't have to worry about this kind of syntax going on. So you don't end up with these really complex and convoluted observable chains. This is just going to be handled for you by the Kotlin compiler, or the implementation generated by the Kotlin compiler. And we've already seen some implementations of this manifest in terms of architecture. If you've heard of the Cache App molecule library, this is really quite cool how we can use compose to build our state classes. So we have everything that we'd have in a presenter, for example, actually in a molecules. So they're called molecules. And then inside you'd have all your composable logic. And I really recommend checking it out. It's a lot of fun to play with. And it looks a little bit like this. So you're utilizing compose runtime to build a state flow here. And you this remember function and a launched effect. So it's then making sure that this is going to be recomposed when this value changed, and it respects this in the actual implementation. I did talk with one of the authors on this in droidcon New York in 2022. Recommend checking this out. Again, links at end. So knowing compose runtime is capable of managing a tree of nodes means we can kind of exploit this as an architecture in the same way that Molecule did. And taking frameworks and applying them to compose is fine. It works for a lot of cases. But maybe you want to consider compose first architectures. Why not? So I'd like to introduce you to Circuit from the folks at Slack. Circuit is a community contributed library from Multiplatform. It takes existing approaches from Cash App Broadway, for example, and workflow, and it's developed primarily by Zach and Kieran and the rest of the folks at Slack. Designed with Compose in mind, powered with Compose runtime, with the same principal tenets, separation of presenter and UI, UDF all the way, unidirectional data flow all the way through. Nice separation here as well. Too far. And it's just respectful of these kind of core tenets of Compose API design. Screens are keyed by an appropriately named screen class. UDP concept revolves around your state. So unfortunately at the moment it does need to be parcelable. I've tried to convince them to move away from this, but it's quite deeply ingrained into the implementation. But not everything's perfect. And then you have the presenters, which are separated from the UI, responsible for the creation of the state. So you've got this composable function here that you then create your state class. You have all your network operations, for example, any state emissions where you want to kind of invalidate things and kind of keep on going. And then you have your basic UI, which just takes that state and a modifier, because we're good people, and just renders that provided state. So the separation of the UI and the presenter is made very clear and very intrinsic to how you build your application. Then, of course, you have some glue code to set this all up, where you're setting the presenters and the UIs. These aren't actually directly interlocked together. You just have to kind of be a good citizen and make sure that they're both provided. But it will fail safely if they're not there. So when you're testing it, you'll be able to find out that there's something missing. And that's kind of about it, really. And it introduces this really interesting navigation style of event propagation through this event sync. The event sync is actually modeled into the state class itself, which might be a little bit weird at first because you think of these things as separate, but you're always going to have some sort of event operation, event emission, so it makes sense to actually compile this into the state. And then this can be handled by a presenter and then handled by the UI appropriately. And it looks a little bit like this. So you might have, you just navigate to go-to. You provide this as a parameter to your presenter, which is provided by the circuit's glue code. And just quite simply navigate to your screen. As I said, the screens are keyed by object class that you create. So you're just saying go to this screen, and then it's there. It's quite nice. It's much more in-depth discussion about this with Zach and Kieran. This was at Kotlin Conf last year. I recommend checking out this talk as well. And there's also these Android extensions for other activities and custom tabs, some effects for logging and analytics, gesture prediction and gesture navigation, these nice concepts that we have from the predictive back gesture, really quite nice, and overlay support for bottom sheet navigation. But there's a bit of more secret sauce to this, and a concept that's introduced with Circuit is this idea of remember retained. Now Circuit is kind of really nice really refreshing because it sort of moves away from this view model and lifecycle structure that we're so familiar with on Android. You might be, familiar with having to manage your lifecycle scope, making sure that your states are being observed only on the right scope that you're actually implementing for the lifecycle. But then remember retain kind of allows us to do away with this. So this kind of weird stuff with repeat on lifecycle, forget about it. This weird stuff with collector state, don't need to use it anymore. And why might we want to do that? Well, remembering that a view model is our sort of go-to mechanism for persisting state through configuration change, and that's sort of its responsibility, we don't need to use this anymore. We can use this remember retained object. So we can actually just go ahead and get rid of view models. As I mentioned, I don't like them. And it looks a little like this. You have a presenter, and you have this produce retained state, or you can use remember retained. And then because the presenter is scoped to the UI, the presenter will be thrown away at the end of the composition, but everything that you do inside the retained state will be retained for the next presenter. Now it's going to be executed again when you create the presenter again, but it's going to be instantiated with the same value that it had. So maybe if you're doing a network operation to fetch some details from backend, you'll start off the presenter with the same information that you had when you're recomposed. So it provides a much nicer and cleaner UI for your users. And you might think as well, this works a little bit similar to Remember Savable, and that's true, it kind of does. But what you provide to Remember Savable must be a parsable implementation. The difference here with Remember Retained is that it's just an object in memory. So that's quite nice that you can use this for sort of caching reasons. You should probably still use remember savable for things like navigation indexes and things where you actually want to make sure the user returns to the same screen. But we can use remember retain for caching retained data and makes it a little bit nicer. There's a much better elaboration about this on Chris Bain's article, Retaining Beyond View Models. What he does here is using the retained remember retained creates a remember retained coroutine scope, and this coroutine scope is then retained through the presenter through UI configurations to actually perform some long-running coroutine tasks. So things like where you might be tempted to use like an application scope, which is really hacky, or having like a non-cancelable or something, you can then use this kind of coroutine scope, which is going to be retained through configuration change to operate things as well. So again, another reason why we can just drop the view model. Some nice examples about this online, so you can go check them out. This is the Chris Bain's TV library. Actually, really quite enjoy this app. I use it most days. There's the catch-up library from Zach Swear as well, demonstrating this. And then Field Spotter as well, and my own personal playground, shameless self-promotion. This is just where I mess about with new technologies and try things out and break stuff. But of course, full disclosure, there is a lot of bias here. There's already a lot of options available to us. I really like using Circuit because it's just enjoyable, but that doesn't necessarily mean that'll be true for you. I recommend trying out different ones. Again, try Decompose, for example. But there's other libraries available for this as well. I just didn't have time to go into everything. So there's the Voyager library as well, which is a little bit like the navigation provided by Jetpack, but kind of more composy. Keys are keyed again by screen and class, and just simply added and removed from Backstack. It still expects a passable implementation for Android, but allows consumers to kind of opt out of this, so you don't actually have to have this implementation, but then you should for Android implementations. There's also the gesture-focused Appy X from Bumble. Yeah, except there's a bit more gesture control about this, a little bit more lightweight. And pre-compose, which is very much similar to Jetpack navigation, but with a few tweaks for compose. I tried to make a comparison against these to sort of make it a bit easier to evaluate the differences in these libraries against each other, but to be honest, it's actually just quite subjective. Each one of these libraries may or may not work for your app, for your team, for your project, or maybe you just enjoy one more than the other. And that's totally fine. I tried to give some metrics here, but like I said, it's like finger in the air, really kind of subjective things. So you've got some of them that are designed with compose first in mind. Some of them have very well documented. Some are easy to use, and some have very opinionated additional API services. And ultimately, what is it? What are these features that we look for in these libraries? Like, what's the reason? Like, are we passing off configuration between ease of use? Maybe you don't even want to migrate at all. Maybe you're happy with your current solution, which is totally fine if that's working for you. But presenting these as just options, because it can be quite difficult to think of. Like, well, I'm starting a new project. I want to use Compose Multiplatform, but what navigation options are available? What should I go for? But if you have a solution, it's totally fine to stick with it. I always like to use this comparison as well at the end. It's something I always try and emphasize, that good code is code that is most easily removable, whether it's following standards, whether it's easily isolated. Less code is better code. So, the library that you can use that allows you to write the least amount of code is probably a good one, probably the best for you, but it's all subjective. Thanks. Cool. I guess we have time for questions, I think. Yeah. So the question there was on whether to use KMM or CMP for multi-platform projects, whether you have an iOS. Yeah. So I work on some projects where a lot of the shared logic is done in KMP, and then CMP is just used for the Android part, and then you can have that for like desktop, for example, as well. It's not mandatory that you have to use CMP for iOS, and some people prefer not to because they might want to use the native UI components that are more familiar. There is a Cupertino theme for Compose that you can use that gives you kind of more look and feel iOS components. But for navigation, it's like I said, it's subjective. So whatever you think is going to work best for your team. Circuit has a lot of demonstration, a lot of apps using iOS. So the Slack team are actually using this in the Slack app themselves. So the navigation works totally fine on iOS. Same as it does for the other platforms as well. With Decompose as well, would work fine, but that's more KMP than it is Compose. I would say just try it out and see what you're more comfortable with. You want to make sure that you're not slowed down in development process by trying to figure out a new library. Yeah. Yeah, so all of these examples should be fine for iOS, and ultimately your client's not really going to see. Ultimately, they're not going to see how the implementation is under the hood. It's just they're going to see how it works when they're actually using it. So all of these libraries respect that and how it should be used for that platform. No worries. Yep. If you can easily remove circuit and move to another library, then perhaps yes. I mean, I'm just imploring people to write less code. Yeah, there's a bit of a contradiction there because using something that's for your architecture is sort of like the fundamental part of your application. So it's very difficult to move from one architecture to another. But if you can build components like having UI components that are separated from the presenter, then something like Circuit could just sit at the top and then passing a state to your UI composables is going to be it doesn't have anything to do with Circuit. It's just completely isolated. Circuit is just controlling the top level architecture, how it gets from one screen to the next. The screens themselves are separated from that. So in theory, yeah, you could separate your UI implementation entirely, and it wouldn't be locking you to that framework, so you could then move to navigation. I actually tried this on my Playground app, because I use Circuit extensively, and I wanted to just try out moving to Jetpack navigation, just to see if it works, and it wasn't so hard, actually. So it's how you structure it as well. I mean, if you follow the guidelines, then you should be okay, but you can also be disciplined on yourself to think like, okay, well, I don't want to build this directly into my navigation hierarchy. I just want the navigation to sit like elsewhere at the top and then manage this separately. So if you build your UI components individually, then you should be able to kind of move from one to the other. You're also not locked into using one for everything. You can use Circuit or navigation for a small part of your application if you want to try it out in a part of a module. Hope that answers the question. Yeah. Good question. Will these libraries interact with Google Canonical Layouts? So this is the adaptive libraries, right? Yeah. I did try one out myself, and I think the support isn't quite there yet because with the adaptive library, it has its own like navigator to work with that. Yeah. You can introduce the concept of fragments, so you could probably achieve the same thing in a different way. But if you wanted to use the adaptive library from Google, it probably wouldn't work so well with that. But the canonical layouts as a concept, I think, yeah, I think it should be. I've not tried it myself, but I think it should be feasible.